Welcome, dear listener, to this journey into the depths of the ocean, a realm so vast and mysterious that it has captivated the human imagination for centuries. As you settle in for a restful slumber, allow me to paint a picture of the wonders that lie beneath the waves, a world that we have only begun to understand in recent times. But before we dive into the abyss, I invite you to pause for a moment and share with us where in the world you are listening from and what time of day it is for you. Are you nestled in your bed, the glow of the moon filtering through your window, or perhaps you're enjoying a quiet afternoon, seeking a moment of calm amidst the bustle of the day? Wherever you may be, know that you are part of a global community of curious minds all drawn to the allure of the deep. If you find yourself captivated by the tales of intrepid explorers and the marvels they uncovered, I encourage you to subscribe to this channel. Here, we embark on gentle explorations of the natural world, weaving together history and science in a tapestry of soothing narratives designed to lull you into a peaceful slumber. And so, as you close your eyes and let your mind drift, imagine yourself standing on the shore, gazing out at the vast expanse of the ocean. The rhythmic lapping of the waves against the sand is a lullaby, a gentle reminder of the ceaseless motion of the sea. For millennia, humans have been drawn to these azure waters, marveling at their power and mystery, yet rarely venturing far beneath the surface. It may surprise you to learn that the oceans cover more than 70% of our planet's surface, an area so immense that it dwarfs the land we call home. And yet, for all our technological advancements and insatiable curiosity, we have explored less than 10% of these watery depths. The deep ocean remains one of the last true frontiers on Earth, a realm where the unknown still reigns supreme. For much of human history, the deep sea was thought to be a lifeless void, a cold and dark abyss where nothing could survive. The sheer weight of the water above, the absence of sunlight, and the crushing pressure seemed to preclude the possibility of life. It was a place of myths and monsters, where the imagination ran wild and the boundaries of reality blurred. But as we shall see, the story of deep-sea exploration is one of perseverance, ingenuity, and a thirst for knowledge that could not be quenched. It is a tale of brave men and women who dared to venture into the unknown, armed with little more than their wits and a burning desire to unravel the secrets of the deep. Our journey begins not in the modern era, with its sophisticated submersibles and high-tech sensors, but in the mists of antiquity, with a man whose ideas would shape the course of scientific inquiry for centuries to come. His name was Aristotle, and though he lived over 2,000 years ago, his insights into the natural world continue to resonate today. Aristotle was a Greek philosopher and polymath, a man whose insatiable curiosity led him to explore fields as diverse as biology, physics, metaphysics, and politics. He was a student of Plato and a teacher of Alexander the Great, a towering figure whose ideas would form the bedrock of Western thought for centuries to come. But it was in the realm of marine biology that Aristotle made some of his most enduring contributions. In the 4th century BC, he became the first scientific thinker to reason that there might be life in the cold, dark waters of the deep sea. This was a radical notion at the time, for most people believed that the oceans were a barren wasteland, devoid of any living creatures. Aristotle's insights were based on the occasional sea monsters that washed up on the shores of the Mediterranean. These strange, often grotesque creatures bore little resemblance to the fish and other marine life that people were familiar with. Some had long, serpentine bodies, while others sported sharp teeth and bioluminescent lures. To Aristotle, these creatures were proof that the deep sea was not a lifeless void, but a realm teeming with strange and wondrous beings. He reasoned that if such creatures could exist in the shallow waters near the shore, then surely there must be even more exotic life forms lurking in the depths. Of course, Aristotle had no way of confirming his hypothesis. The technology to explore the deep sea simply did not exist in his time, but his ideas would plant a seed in the minds of future generations, a tantalizing hint of the mysteries that lay beneath the waves. It would be centuries before Aristotle's musings were taken up in earnest. In the intervening years, the deep sea remained a realm of myth and speculation, a place where the imagination ran wild. Sailors told tales of sea serpents and mermaids, of ghostly ships and lost civilizations. But amidst these fanciful stories, there were glimmers of truth. In the 1st century AD, the Roman naturalist Pliny the Elder compiled a monumental work called the Naturalis Historia, a compendium of all the knowledge of the natural world that had been accumulated up to that point. In his writings, Pliny described a number of strange creatures that had been hauled up from the depths by fishermen. There were giant squids with eyes the size of dinner plates, and fish that glowed in the dark like fireflies. Pliny's descriptions were often exaggerated and embellished, but they hinted at a world beyond the reach of human knowledge, a realm where the normal rules of biology did not apply. It would be another 17 centuries before the first systematic attempts were made to explore the deep sea. In the late 18th century, a British naval officer named Captain James Cook set out on a series of voyages that would revolutionise our understanding of the world's oceans. Cook was a master navigator and a meticulous observer, a man whose scientific curiosity was matched only by his bravery and determination. On his first voyage, he set out to observe the transit of Venus across the face of the Sun, an astronomical event that would help scientists calculate the distance between the Earth and the Sun. But Cook's interests extended far beyond astronomy. He was also fascinated by the natural world, and he made it his mission to collect specimens and observations of the plants and animals he encountered on his travels. It was on his second voyage, however, that Cook made his most significant contributions to oceanography. Using a weighted rope, he was able to measure ocean depths of up to 7,200 feet, far deeper than anyone had ever done before. Cook's measurements revealed that the oceans were much deeper than previously thought, and that they contained a vast and unexplored realm that was entirely unknown to science. Cook's discoveries sparked a wave of interest in the deep sea, and in the decades that followed, a number of expeditions were launched to explore this mysterious realm. One of the most significant of these was led by a British naturalist named Edward Forbes. Forbes was a pioneering marine biologist, a man whose passion for the natural world had led him to explore the coastlines of Europe and the Mediterranean in search of new species. In the 1830s, he began to focus his attention on the deep sea, using a dredge to collect specimens from depths of up to 1,800 feet. What Forbes found was nothing short of astonishing. His dredges brought up a dazzling array of creatures, from delicate sea stars and feathery anemones to bizarre fish with glowing lures and razor-sharp teeth. Forbes was convinced that he had discovered a new frontier in marine biology, a realm that was every bit as rich and diverse as the shallow waters near the shore. But Forbes's enthusiasm was tempered by a nagging doubt. As he collected specimens from deeper and deeper waters, he noticed that the number of species began to decline. By the time he reached depths of around 1,800 feet, he found that there was almost no life at all. Forbes concluded that there was a limit to the depth at which life could exist in the ocean. He called this the Azoic hypothesis, from the Greek word for without life. According to Forbes, the deep sea was a barren wasteland, a place where the absence of sunlight and the crushing pressure of the water made it impossible for anything to survive. Forbes's hypothesis was widely accepted by the scientific community of his time. It seemed to make sense, after all. The deep sea was a cold, dark and inhospitable place, far removed from the warm, sunlit waters where most marine life was found. But as we shall see, Forbes was wrong. The deep sea was not a lifeless void, but a realm teeming with strange and wondrous creatures, adapted in ways that defied the imagination. It would take a new generation of explorers armed with cutting-edge technology and an insatiable thirst for knowledge to unravel the secrets of the abyss. The heroic age of deep sea. Exploration, as it came to be known, began in earnest in the late 19th century. It was a time of great scientific and technological advancement, when the boundaries of human knowledge were being pushed to their limits. One of the most significant expeditions of this era was the HMS Challenger expedition, which set out from England in 1872 on a 4-year mission to survey the world's oceans. The Challenger was a state-of-the-art research vessel, equipped with the latest scientific instruments and a crew of experienced naturalists and oceanographers. Over the course of their journey, the Challenger crew collected an astonishing array of data and specimens from the depths of the ocean. They dredged the seafloor, took water samples, and measured ocean currents and temperatures, and everywhere they looked they found evidence of life. From the icy waters of the Antarctic to the tropical seas of the Pacific, the Challenger crew discovered a dazzling array of creatures, many of which had never been seen before. There were glass sponges and feathery crinoids, bioluminescent fish, and giant isopods, and in every sample they took, no matter how deep, they found living organisms. The Challenger expedition dealt a decisive blow to Forbes's Azoic hypothesis. It was now clear that life existed at every depth of the ocean, from the sunlit surface waters to the cold, dark abyss. The deep sea was not a barren wasteland, but a realm of unimaginable diversity and complexity. In the years that followed, other expeditions would build on the work of the Challenger crew. In 1899, the Dutch HNLMS Sibberger set out to explore the deep basins of the Indo-Pacific, cataloguing thousands of new species along the way. And in the early 20th century, the American research vessel Albatross made some of the deepest trawls to date, using steel cable to haul up creatures from the abyss. But perhaps the most iconic figures of the heroic age were William Beebe and Otis Barton, two American explorers who made history in the 1930s with their daring descents into the deep. Beebe was a naturalist and adventurer, a man whose passion for the natural world had led him to explore the jungles of South America and the coral reefs of the Caribbean. Barton was an engineer and inventor, a man whose technical skills would prove invaluable in the challenges ahead. Together, Beebe and Barton designed and built the bathysphere, a steel sphere with thick quartz windows that would allow them to observe the depths directly. It was a cramped and claustrophobic space, barely large enough for two men to stand upright. But it was also a marvel of engineering, capable of withstanding the crushing pressure of the deep sea. In 1934, Beebe and Barton made their first descent in the bathysphere, lowering themselves into the waters off the coast of Bermuda. As they sank deeper and deeper, the light from the surface gradually faded away, replaced by an eerie bioluminescent glow. Through the thick quartz windows, Beebe and Barton beheld a world that no human had ever seen before. Strange ghostly creatures drifted past, their bodies translucent and shimmering in the dim light. Jellyfish pulsed and shimmered, their tentacles trailing behind them like streamers. And everywhere they looked they saw evidence of life, thriving in conditions that would crush a human being in an instant. Over the course of several dives, Beebe and Barton descended to depths of over 3,000 feet, setting new records for human exploration of the deep sea. They described alien seascapes of jagged rock formations and towering underwater cliffs, populated by creatures that seemed to defy the laws of nature. Their observations and photographs captured the public imagination, sparking a wave of interest in the deep sea that continues to this day. Beebe's vivid descriptions of the bathysphere dives, published in his book Half Mile Down, became a bestseller and inspired a generation of young explorers to follow in his footsteps. But as groundbreaking as the bathysphere dives were, they were only the beginning. In the decades that followed, new technologies would emerge that would allow us to explore the deep sea in ways that Beebe and Barton could scarcely have imagined. The advent of precision depth echo sounding during World War II, originally developed for submarines, would enable scientists to map the seafloor in unprecedented detail. Submersibles like DSV Alvin, first launched in 1964, would allow researchers to visit the abyss in person, collecting samples and observing the deep sea environment up close. Remotely operated vehicles, or ROVs, would revolutionize deep-sea exploration in the late 20th century. These unmanned robots, tethered to ships by long cables, could be sent to depths far beyond the reach of human divers. Equipped with cameras, sensors, and dexterous manipulators, ROVs have been used to explore everything from the wreckage of the Titanic to the strange and wonderful creatures that inhabit hydrothermal vents on the ocean floor. More recently, autonomous underwater vehicles, or AUVs, have taken deep-sea exploration to new heights. These intelligent, untethered robots can be pre-programmed to survey large areas of the ocean independently, collecting data and images as they go. AUVs have been used to map the seafloor, study ocean currents, and even search for signs of extraterrestrial life on the moons of Jupiter and Saturn. But for all the technological advancements of the past century, the deep sea remains a realm of mystery and wonder. Even with the most sophisticated tools at our disposal, we have only begun to scratch the surface of this vast and alien world. The challenges of life in the deep sea are formidable. The darkness is absolute, The pressure is immense, and food is scarce. Temperatures hover just above freezing, and the water is devoid of sunlight. It is a world of eternal night, where the only light comes from the bioluminescent glow of the creatures that call it home. To survive in such extreme conditions, deep-sea organisms have evolved a dazzling array of adaptations. Many have lost their eyes, their skeletons, and even their muscles, becoming delicate and gelatinous in the process. Others have developed huge mouths and expandable stomachs, allowing them to engulf any rare prey that happens to drift by. Some deep-sea creatures are masters of camouflage, with transparent bodies or red and black coloration that makes them virtually invisible in the dim blue light of the abyss. Others use bioluminescence to attract prey or ward off predators, flashing and shimmering like underwater fireworks. But perhaps the most astonishing adaptations are found in the creatures that inhabit the hydrothermal vents on the ocean floor. These oases of heat and chemicals, spewing from cracks in the Earth's crust, support entire ecosystems that exist independently of sunlight. Tube worms and giant clams thrive on the hydrogen sulfide and other chemicals that would be toxic to most other forms of life. And then there are the microbes, the unseen heroes of the deep sea. These tiny organisms, invisible to the naked eye, are found in every corner of the abyss, from the rocks and mud of the seafloor to the ice and sediments of the polar regions. Some scientists believe that the biomass of the deep biosphere, the vast network of microbes that exists beneath the seafloor, may exceed that of all other life on Earth combined. But the deep sea is not just a realm of darkness and scarcity. It is also a place of unexpected oases, where life finds a way to thrive in the most unlikely of places. Take the whale fall, for example. When a whale dies and sinks to the bottom of the ocean, its massive carcass becomes a banquet of bounty for the creatures of the abyss. Scavengers and sulphur eaters flock to the scene, feasting on the whale's flesh and bones for years on end. A single whale fall can support an entire ecosystem, a miniature world within a world. Or consider the woodfall, a similar phenomenon that occurs when logs and other debris from terrestrial storms sink to the seafloor. These sunken logs provide a rare source of food and shelter for deep sea creatures, and may even have played a role in the animals' invasion of the deep millions of years ago. Brine pools, basins of heavy salt water that form lakes on the seafloor, are another unexpected oasis in the abyss. These pools are home to mussels and shrimp that have adapted to the harsh, salty conditions but are toxic to most other forms of life. Methane seeps, like cold cousins to hydrothermal vents, are yet another example of the deep sea's hidden wonders. These leaks of methane gas from the seafloor fuel entire communities of microbes and tube worms, creating miniature ecosystems that exist independently of sunlight. And then there are the seamounts. The darkness of the deep sea is broken only by occasional flashes of bioluminescence, the living light of strange, gelatinous creatures drifting through the abyss. This alien landscape, so different from the bright, active world above, was long thought to be a lifeless void. But as the lights of submersibles and ROVs penetrate ever deeper, they reveal the deep ocean to be a complex tapestry of life, finely adapted to the harsh conditions of the eternal night. One of the most iconic denizens of the deep is the anglerfish, aptly named for the bioluminescent lure that dangles temptingly in front of its cavernous mouth. This ambush predator can engulf prey up to twice its size thanks to its enormous gape and distensible stomach. The anglerfish was one of the first deep-sea creatures discovered, dredged up by the HMS Challenger expedition in the late 19th century. But it would be many decades before its bizarre appearance and lifestyle were fully understood. In the 1930s, American naturalist William Beebe made history by descending into the depths in a cramped steel sphere called the bathysphere. Through its thick quartz windows, Beebe became the first person to observe the deep sea with his own eyes. He described a world of glowing, pulsating creatures moving languidly through the darkness, a league of absolute night, where the blackness grew more intensely black and the blue above more mauve-like and unreal. Beebe's vivid accounts captured the public imagination and inspired a new generation of deep-sea explorers. But it wasn't until the development of unmanned submersibles in the 1960s that scientists could truly begin to study the deep ocean in detail. These remote-controlled vehicles, tethered to ships by long umbilical cords allowed researchers to collect samples, take measurements, and observe deep-sea life without the risks and limitations of human-occupied craft. One of the most remarkable discoveries made possible by this new technology was the existence of hydrothermal vents, deep-sea hot springs that support entire ecosystems based not on sunlight but on chemical energy. These oases in the darkness were first glimpsed in 1977 using the submersible DSV Alvin on a dive to the Galapagos Rift off the coast of Ecuador. What the Alvin's pilots saw through their tiny portholes astonished them. Towering chimneys of mineral-rich water, surrounded by lush communities of giant tube worms, ghostly crabs, and strange eyeless shrimp. The discovery of hydrothermal vents revolutionized our understanding of life on Earth. Here, in the most extreme environment imaginable, entire ecosystems were thriving on the heat and chemicals spewing from cracks in the planet's crust. The microbes that form the base of these food chains don't need sunlight or oxygen. They get their energy by breaking down sulfur compounds in a process called chemosynthesis. This realization expanded the definition of habitability and sparked new theories about how life might have originated in the deep ocean billions of years ago. But hydrothermal vents are just one of many unexpected oases that punctuate the abyssal plain. Whale falls, the sunken carcasses of dead whales, provide a sudden bounty of food in the nutrient-poor deep sea, supporting complex communities of scavengers, opportunists and sulfur eaters for years on end. Woodfalls, formed by trees washed out to sea during storms, play a similar role and may have facilitated the invasion of the deep ocean by wood-boring clams and other animals millions of years ago. Even in the absence of these organic windfalls, life finds a way to eke out an existence in the eternal darkness. Brine pools, basins of super salty water on the seafloor, form toxic lakes that are home to mats of microbes and beds of mussels and shrimp. Methane seeps, like cold cousins to hydrothermal vents, fuel unique ecosystems based on methane-eating bacteria, and seamounts, underwater mountains that rise thousands of meters from the abyssal plain, disrupt deep-sea currents and concentrate nutrients, serving as oases of diversity in the otherwise barren depths. As we've only explored a small fraction of the deep ocean, much remains to be discovered in this alien world beneath the waves. Each expedition seems to reveal creatures and ecosystems stranger than the last. In the Mariana Trench, the deepest point on Earth, shrimp-like amphipods scuttle along the seafloor under pressure more than 1,000 times that at the surface. In the oxygen-starved waters of the Black Sea, delicate carnivorous sponges chase their prey in lazy slow motion. And in the icy darkness beneath the Antarctic ice shelf, ghostly white octopuses incubate their eggs for an astonishing 14 years, the longest known brooding period of any animal. These deep-sea creatures may seem remote from our everyday lives, but they are increasingly vulnerable to human activities. Climate change is altering the chemistry and circulation of the oceans, while the emerging industry of deep-sea mining threatens to destroy habitats before they can even be studied. As we drift off to sleep, we might spare a thought for the alien world that carries on beneath the waves and the secrets that still lie hidden in the eternal night of the abyss. As the sun's rays fade into the twilight and finally wink out in the black abyss, utter darkness envelops the depths. Down here, night is eternal. The deep sea is a world without days, months, or years, just an endless, lightless void. In this cold, pressurized realm, the normal rules of life are reversed. Food is scarce, so animals must make the most of any rare morsel they encounter. The usual daily cycles of activity and rest blend into a constant twilight state. Life slows down to a sluggish, energy-conserving crawl. Metabolism grinds to a bare minimum. Hearts beat only a few times per minute. Breathing nearly stops, muscles atrophy, and skeletons dissolve. Deprived of calcium, bones become watery and flexible. Transparent, gelatinous forms replace solid, opaque bodies. Predators evolve into nightmare monstrosities, all teeth and expandable stomachs. The fang-toothed fish wields dagger-like teeth half the length of its head. Gulper eels can swallow prey twice their size by stretching their elastic jaws. Viperfish sport hinged teeth that fold back to store struggling victims inside their mouths. But for prey, invisibility is the key to survival. In the faint shimmer of bioluminescence, red and black coloration offers perfect camouflage. Certain small crustaceans take transparency a step further. Their shells, muscles and organs turn completely clear. Only their eyes remain pigmented, detecting the faintest traces of light. In fact, vision reaches its peak in the depths. Down here, bioluminescence is the only source of light. Predators like the pelican eel dangle glowing lures to attract curious fish. Vampire squid squirt a distracting blob of glowing liquid to confuse attackers. Countless creatures carry blazing spotlights to pierce the veil of darkness. Perhaps no oasis of life in the abyss is as dazzling as a hydrothermal vent. Fissures in the ocean floor spew superheated water laden with hydrogen sulfide, methane and other chemicals. In this cauldron of toxicity, microbes thrive by harnessing chemical energy rather than sunlight. Giant tube worms, over 2 meters long, cluster in waving forests around the vents. Inside their bodies, specialized bacteria convert chemicals into nutrients. Mussels, clams and shrimp armor themselves against the scorching vent fluid and graze on thriving mats of microbes. Crabs prowl like wolves over the colony, snatching up stray tube worm plumes. Hydrothermal vents are just one of many unexpected havens that punctuate the bleak expanse of the deep-sea floor. Whale carcasses, sunken wood, brine pools, methane seeps, and seamounts all shelter oases of unique creatures found nowhere else on Earth. When a whale dies and sinks, it delivers a massive pulse of food energy to the abyss. The rotting bonanza can support a complex community of worms, mollusks, crabs, and more for up to a century, as the oils slowly seep into the seafloor. Specialized bacteria even eat the bones, extracting fats and sulfur as the skeleton itself disintegrates. Sunken logs washed out to sea by storms offer a similar feast. Wood-boring clams and pill-bug-like isopods gnaw away at the waterlogged wood, excreting sawdust feces that feed other small scavengers. These woodfalls may have been early stepping stones that allowed shallow water species to invade the deep sea. Brine pools form where extra salty water settles into depressions on the seafloor and creates lake-like seascapes. Heavier than normal seawater, the briny shorelines trap mussels, shrimp and tube worms within their confines. To other creatures, the toxic brine is lethal. Methane seeps leak from cracks in the sediment, almost like cold cousins of hydrothermal vents. Here, specialized bacteria eat the methane and provide the base of a unique food chain, supporting tube worms, mussels, and crustaceans very similar to those at vents. The icy methane can even form solid hydrate mounds that resemble stony corals. Seamounts are massive extinct volcanoes that rise thousands of meters above the abyssal plain without breaking the surface. They interrupt the flow of deep currents, causing eddies that concentrate nutrients and microorganisms. Sponges, corals, fish, and other filter feeders gather in dense crowds on the rocky slopes. Many seamount species are found nowhere else, making these underwater islands hotspots of deep ocean diversity. Even away from these specialized habitats, the muddy ooze of the seafloor seethes with microbial life. Bacteria, archaea, and single-celled protists live by the trillions between every grain of sediment, recycling the dead organic matter that constantly rains down from above. This deep biosphere, buried in the seabed and oceanic crust, may contain more than half of Earth's total biomass. As our minds drift through these alien seascapes, it's humbling to realize how little we truly know about the deep oceans. Whenever scientists venture into the depths, they discover bizarre new species and ecosystems. Over 80% of this world remains unmapped, unobserved, and unexplored. Today, new technologies are finally shining light into the depths. Fleets of robot submersibles crisscross the seafloor, streaming video and collecting samples. Autonomous underwater drones scout the abyss for months at a time. Manned submersibles carry explorers to the deepest trenches for face-to-face encounters. Bit by bit, the mysteries of the deep are coming into focus. But as we uncover the treasures of the abyss, we're also learning how fragile they can be. Deep-sea trawling scrapes clear 2 million square kilometers of seafloor habitat per year, an area the size of Mexico. Seabed mining looms as an emerging threat to the vent and seep communities we barely understand. And climate change is altering the very chemistry of the oceans faster than in millions of years. The bizarre and wonderful life of the deep hangs in a delicate balance. As much as any other species, our fate is tied to the health of the oceans and the myriad creatures that inhabit them, from the sunlit shallows to the midnight zone. So as we drift off to sleep, dreaming of the alien world far below the waves, we can rest a bit easier knowing that with exploration comes awareness, and with awareness comes the drive to understand and protect. The dark depths may be out of sight, but thanks to the curiosity and ingenuity of scientists around the world, they are no longer completely out of mind. Piece by piece, drop by drop, we are shedding light on the largest, least known habitat on Earth, the mysterious realm of the deep oceans. The vast, dark abyss of the deep sea has long haunted the human imagination. For centuries, the inky blackness of the depths conjured tales of mysterious leviathans, ravenous sea serpents, and mythical behemoths drifting in an unseen world beneath the waves. Even as recently as 200 years ago, most scientists believed the deep ocean to be a freezing, lightless void, a dark desert utterly devoid of life. How could anything, they reasoned, hope to eke out an existence in such a hostile environment, cut off from the sun's nourishing rays? It took a series of intrepid explorers, armed with ingenuity, fortitude, and an unquenchable thirst for knowledge, to gradually pierce the veil of mystery shrouding the deep sea. Their discoveries would forever transform our understanding of the world's oceans and the life they contain. One of the first to hint at the strange organisms lurking in the depths was Pliny the Elder, an ancient Roman naturalist who lived in the 1st century AD. In his sprawling encyclopedia, Natural History, Pliny recounted the tales of fishermen who spoke of hauling up bizarre creatures entangled in their nets from the deep. Monstrous sharks, sawfish, giant squid. While some of these accounts no doubt sprang from seaside legend and the human penchant for exaggeration, others hinted at genuine denizens of the deep that were rare or unknown to science at the time. For over 1,000 years after Pliny, little progress was made in exploring the oceans. The seafloor was simply too deep and inaccessible to the technologies of the age. This all began to change in the 18th century, however, with the voyages of Captain James Cook. A brilliant navigator and explorer, Cook commanded 3 epic expeditions that sailed to the far reaches of the globe, filling in vast swathes of the world map. During his first voyage, Cook deployed weighted lines to measure the depth of the ocean at various points. To his astonishment, the lines revealed that the oceans were much, much deeper than anyone had previously imagined. Cook recorded depths of over 7,200 feet, and even then, his crude weight and rope had failed to strike bottom. For the first time, humans began to grasp the sheer immensity and volume of the world's oceans. If the seas were so incomprehensibly deep, what strange creatures might dwell in that chilly abyss, far from the reach of fishermen's nets? In the early 19th century, the British naturalist Edward Forbes set out to answer that question. Between 1841 and 1842, Forbes conducted a series of pioneering dredging operations in the Aegean Sea, dragging a metal scoop along the seafloor to collect samples of mud, rocks, and any organisms living on the bottom. At depths of up to 1,800 feet, Forbes discovered an astounding menagerie of novel creatures, delicate sea lilies, luminous glass sponges, and bizarre fish found nowhere else on Earth. Yet below about 1,800 feet, Forbes's dredges came up largely empty, containing little more than mud and sand. From these results, Forbes developed his infamous Azoic hypothesis. He postulated that life simply could not exist below a certain depth, with the eternal darkness, freezing cold, and crushing pressure of the abyss imposing an impenetrable barrier to living organisms. For a time, the Azoic hypothesis was widely accepted in scientific circles. The oceans, it seemed, were not bottomless, and neither was the variety of life they contained. As is so often the case in science, however, this tidy consensus would not last for long. In the 1860s, researchers began to take a closer look at the mud and ooze recovered from Forbes's supposedly Azoic dredges. To their amazement, they discovered that these samples were actually teeming with living organisms. They were just far too small to be readily visible to the naked eye. Microscopic foraminifera, radiolarians, and other protists abounded in seafloor sediments from even the greatest depths. The abyss, it appeared, was far from lifeless. It would take the voyage of HMS Challenger to shatter the Azoic theory once and for all. Launched in 1872, the Challenger expedition was the world's first global oceanographic cruise, circling the globe for 4 years to systematically catalogue the mysteries of the deep. Under the scientific supervision of Charles Wyville Thompson, the Challenger's crew dredged up thousands of samples from the far reaches of the Atlantic, Pacific and Indian Oceans. Everywhere they looked, Thompson and his colleagues discovered life. From the abyssal plains to the Hadal depths of oceanic trenches over 5 miles deep, the Challenger expedition recovered a breathtaking diversity of deep-sea organisms. Delicate sea stars, luminous anglerfish, and nightmare-inducing viperfish were among the fantastical creatures hauled up from the deep. Even more shocking were the otherworldly invertebrates clinging to the slopes of underwater mountains: crimson-lipped tube worms, giant clams, and armoured snails, thriving in the total absence of sunlight. With each passing day, the Challenger's crew realised they had stumbled upon an alien world, a deep sea, in Thompson's words, as rich in variety of life as the shallower waters. The age of deep-sea exploration had begun in earnest. In the wake of the Challenger expedition, an international race commenced to probe ever deeper into the ocean abyss with bigger ships and better technology. In the Netherlands, the HNLMS Siboga expedition, 1899 to 1900, undertook a 3-year survey of the deep basins around Indonesia, revealing the incredible biodiversity of the Coral Triangle region. Across the Atlantic, the US Fish Commission vessel RV Albatross mounted a series of ambitious cruises in the early 1900s, using steel cable to sink its trawls to the abyssal seafloor. Among the Albatross's many discoveries were the gulper eel, pelican eel, and abyssal holothurians, the bizarre sea cucumbers that would later be nicknamed sea pigs for their plump, pink, translucent bodies. Yet as fascinating as these specimens were, they represented only fleeting glimpses of the deep, dead organisms wrenched from their habitat and hauled up to the harsh light of the surface. To truly know the deep sea would require observing these creatures in their natural environment, a feat long thought impossible due to the immense pressures of the deep. In the 1930s, a daring engineer and adventurous naturalist joined forces to conquer that final frontier. Otis Barton was a Harvard-trained engineer gripped by an audacious dream to build a diving capsule that could transport humans into the deepest reaches of the ocean. William Beebe was a prominent naturalist and early pioneer of scuba diving, determined to become the first scientist to observe the abyss with his own eyes. Together, they would make history. Combining Barton's technical ingenuity with Beebe's scientific knowledge, the duo constructed a revolutionary vessel, the bathysphere. A tiny steel ball less than 5 feet in diameter, the bathysphere boasted walls more than an inch thick, with a trio of inward curving quartz windows to withstand the crushing pressures of the deep. Equipped with spotlights, a telephone line and oxygen tanks, the cramped capsule was just large enough to accommodate 2 people, Barton and Beebe. Beginning in 1930, Beebe and Barton conducted a series of manned descents off the coast of Bermuda, lowering their bathysphere into the depths on a steel cable. With each plunge into the abyss, they crossed new thresholds, 800 feet, then 1,400 feet, then 2,200 feet. Peering out through the thick quartz windows, they marvelled at the alien seascapes scrolling by, bioluminescent fireflies drifting past like underwater stars, spectral anglerfish luring prey with their luminous lures, and ethereal siphonophores pulsing by like living chandeliers. In 1934, Barton and Beebe made their deepest dive yet, a harrowing plunge to 3,028 feet beneath the waves. There, in the dim blue void, they glimpsed a surreal creature unlike any they had seen before. A strange, pale-bodied fish, with wing-like fins, a whip-like tail, and oval eyes that glowed a spectral green in the bathysphere's floodlights. Beebe dubbed it the abyssal hatchetfish for its hatchet-shaped body, and marvelled that here, in this otherworldly realm of eternal darkness, were creatures even his scientific imagination had never conceived of. I knew I should never again look upon the stars without remembering their active, living counterparts swimming about in that terrific pressure, Beebe later wrote. The bathysphere dives of the 1930s cracked open a portal to the deep sea, but only a tiny aperture. The vast majority of the abyssal ocean remained unexplored, a lightless mystery lurking beneath the waves. It would take the development of new technologies in the crucible of World War to truly illuminate the largest and most alien habitat on our planet. The advent of sonar, sound navigation and ranging, in the 1940s revolutionized our understanding of the deep ocean floor. Originally developed to detect enemy submarines, sonar used pings of sound to map out the contours of the seabed in astounding detail, revealing for the first time the serrated topography of the seafloor. Contrary to previous beliefs, the ocean bottom was anything but a featureless plain. Instead, it was riven with plunging trenches, soaring seamounts, and vast underwater mountain ranges to rival any on land. This new knowledge of the variegated deep-sea floor would soon yield profound discoveries. In 1977, a team of geologists diving in the DSV Alvin submersible happened upon a jarring sight near the Galapagos Islands. Clouds of billowing black smoke gushing from volcanic vents in the seafloor. As the sub drew closer, the scientists were stunned to find these cracks teeming with life. Giant tube worms, ghostly crabs, and blood-red octope, thriving in the total absence of sunlight. In time, these oases would become known as hydrothermal vents, deep-sea hot springs where superheated water surges out of cracks in the Earth's crust. The scalding vent fluid, it turns out, is rich in dissolved minerals and chemicals that can sustain life even without the sun's energy. Microbes oxidize hydrogen sulfide to harness energy, forming the basis for whole ecosystems of larger creatures that feed on the microbes or each other. The discovery of hydrothermal vents was a revelation. For the first time, we understood that life could flourish independently of the sun, relying instead on the Earth's internal heat and chemical energy. If such oases could exist on our own planet, might they not also arise on alien worlds, in the dark oceans of Europa or Enceladus? The hydrothermal vents of the deep sea had given us a new understanding of the tenacity of life, and a new place to search for it beyond Earth. As remarkable as hydrothermal vents are, they represent just one facet of the rich tapestry of the deep sea. The abyssal plains, those vast muddy expanses that cover over half of Earth's surface, harbour their own unexpected oases of life in the lightless depths. In the 1980s, marine biologists exploring the abyssal seafloor stumbled upon an astounding sight. The scattered skeletons of dead whales, some the size of school buses resting on the ocean bottom. Far from being stagnant boneyards, however, these whale falls were hubs of activity, veritable banquets of bounty on the desolate abyssal plain. When a massive whale dies and sinks to the seafloor, its carcass offers up a sudden jackpot of food, in a realm where meals are agonizingly scarce. A single whale fall can provide sustenance to deep-sea scavengers for years or even decades, supporting a complex succession of opportunistic organisms. First to arrive are the mobile scavengers, deep-sea sharks, rat-tails and hagfish, eagerly stripping the most nutritious flesh from the carcass. In their wake come the bone-eating worms and zombie crabs, specialized to bore into and feed on the tough whale skeleton itself. Finally, as the bones decompose, they release a burst of sulfides that can sustain mats of bacteria and tube worms for a decade or more, until the very last of the carcass is gone. These insights into whalefall ecology were hard-won. In 2006, marine biologist Craig Smith of the University of Hawaii conducted a daring experiment. Smith and his colleagues hauled a 30-ton grey whale carcass out to sea and deposited it on the deep sea floor off the California coast. Then, they monitored this whale fall with remotely operated vehicles, ROVs, and autonomous seafloor landers over the course of 6 years, documenting in time-lapse the arrival of different scavengers and succession of organisms. Smith's experiment shed light on a phenomenon that would have been impossible for the Challenger or Albatross expeditions to study. After all, whale falls are unpredictable, widely scattered, and slow to unfold. Yet they likely play a key role in the dispersal and evolution of deep-sea life, serving as stepping-stone habitats for creatures to hop across the abyssal plains. Remarkably, whale falls are not the only oases of food on the deep ocean floor. The abyss also harbours dense thickets of life crowded around sunken logs, beds of kelp and even shipwrecked boats, all rare bonanzas of food and shelter in the deep sea. Perhaps most intriguing of all are the so-called brine pools, lakes of dense, ultra-salty water that occasionally form in depressions on the seafloor. In the Gulf of Mexico, for example, brine from ancient salt deposits sometimes seeps up through the sediment, accumulating in seafloor basins. There it forms pools of water up to 4 times saltier than the overlying ocean. To most marine life, these hypersaline lakes are toxic dead zones. Any creature that swims into one will perish within minutes as the salt sucks the water from its cells. But where there are rules in nature, there are also bizarre exceptions. In the 1980s, oceanographers exploring brine pools off the coast of Florida discovered lush beds of mussels growing around the edges of these salt lakes, despite the lethal salinity of the brine. Genetic studies later revealed that these mussels belong to the genus Bethymodiolus, the same group of deep-sea mussels found at hydrothermal vents. It appears these mussels have evolved to tolerate extreme salinity as well as searing heat, allowing them to exploit yet another niche of chemical energy on the seafloor. The deep oceans continue to yield such surprises with each passing year, as marine scientists develop new technologies to explore this alien realm. Autonomous underwater vehicles, AUVs, intelligent deep-sea drones, now roam the depths for months at a time, mapping the seafloor and collecting samples beyond the reach of any ship. Networks of seafloor observatories, like the Neptune Array off the coast of Washington state, bring the deep ocean onto the internet with live video feeds and real-time data on everything from whale songs to the chemistry of the water. Yet for all these advances, we have still barely scratched the surface of the deep sea. Scientists estimate that over 90% of the ocean remains unexplored, and that for every known species living in the depths, there may be dozens or even hundreds yet to be discovered. The abyssal plains likely conceal untold legions of microbes, some of which may hold the key to new antibiotics or cancer drugs. The slopes of deep-sea seamounts almost certainly harbour thousands of unique species found nowhere else on Earth. Perhaps most exciting of all are the tantalising hints of life in the deepest deep sea, the Hadal realm of oceanic trenches. In the early 2000s, robotic landers deployed by the Japanese Kaiko project returned fuzzy images of large white shrimp-like creatures skittering across the floor of the Mariana Trench, 7 miles down and under bone-crushing pressures 1,000 times that at the surface. Later expeditions would recover these enigmatic organisms and determine them to be a new genus of snailfish. Translucent jelly-bodied fish, apparently uniquely adapted to the immense pressures of the Hadal depths. What other wonders might await discovery in the inky canyons of the Mariana Trench and other Hadal zones? Only further exploration will tell. For all its vastness and all its strangeness, however, the deep ocean is far from immune to human influence. As our technologies grow more advanced, so does our reach into the abyss, and our capacity to damage its delicate ecosystems. Bottom trawling, the practice of dragging weighted nets across the seafloor, gouges scars in ancient deepwater corals and sponge fields that may take centuries to heal. Seabed mining, an emerging industry still in its infancy, threatens to dredge up vast swathes of the abyssal plains in the hunt for rare metals and minerals. A changing climate already seems to be altering the chemistry of the deep sea, making its waters more acidic and less oxygenated even as the surface warms. If there is one lesson to be drawn from the centuries-long quest to, the darkness of the abyss was long thought to be a barren void, devoid of life, but the heroic age of deep-sea exploration would gradually reveal the hitherto unimagined creatures and oases hidden within that perpetual night. In the closing decades of the 19th century, the first systematic survey of the world's oceans was launched aboard the HMS Challenger. For 4 years, this grand expedition circled the globe, sounding the depths and dredging up samples from the seafloor at hundreds of stations. Hauling up their trawling nets from as deep as 5 miles down, the Challenger's naturalists were astounded to discover living creatures at every depth they sampled. From delicate glass sponges to nightmare-inducing fangtooth fish, a pageant of life was unveiled from those abyssal plains so recently thought Azoic. The Challenger expedition marked a paradigm shift, as biologists came to accept that the deep ocean harboured life despite its cold, darkness, and crushing pressure. But glimpsing these marvels second-hand, pickled in preservative jars, was a poor substitute for laying eyes upon them in their natural deep-sea habitat. That feat would not be achieved until the 1930s and the advent of William Beebe and Otis Barton's revolutionary bathosphere. Dangling from a steel cable, this cramped hollow sphere of inch-thick cast iron was the frail cocoon that carried the first humans into the abyss. Sinking into the void off the coast of Bermuda, Beebe and Barton peered out the bathysphere's fist-sized quartz windows as the sunlight faded to endless blue and then utter blackness. In the dim glow of their floodlight, an alien seascape materialized. Strange phosphorescent creatures drifted past the windows, shimmering ctenophores, spectral hatchetfish with tubular telescope eyes, and gelatinous worms undulating like living lace. Beebe, a poetic soul, was moved to describe this fantastic spectacle as a slow, unending dance of fragile dreams. Over a series of dives, Beebe and Barton pushed ever deeper into that eternal night, culminating in a record-breaking descent to over 3,000 feet. But even as they celebrated their achievement, they knew their brief visitations were but the barest glimpse into that uncharted world. The technology to linger in the abyss and explore its furthest reaches was still decades away. It would take a world war and the military imperative to hide submarines in the ocean depths to spur the development of sonar, precision depth sensors, and high-pressure engineering. The bathyscaphe Trieste, applying these wartime innovations, would not conquer the deepest point on Earth, the Mariana Trench, until 1960. The age of the submersible had dawned, granting scientists their first real access to the abyss. Craft like DSV Alvin, launched in 1964, enabled researchers to spend hours on the seafloor, collecting specimens and surveying the terrain with their own eyes. Robotic cameras and manipulator arms expanded their reach, while unmanned tethered and autonomous underwater vehicles opened up vast swathes of the deep for efficient exploration. After centuries of straining to sound out the shape of that hidden world from above, humanity could finally wade out into the abyss and illuminate its secrets. That light has revealed wonders stranger than the speculative imaginings of early naturalists. Delving into the darkness, we've discovered not a barren seascape but an intricate tapestry of deep-sea habitats, each populated by exquisitely adapted creatures. The abyssal plain, though sparsely inhabited compared to the sunlit surface, nonetheless crawls with blind white crustaceans and gelatinous fish with recurved teeth. Seamounts thrust up from those muddy flatlands, their rocky flanks encrusted with vibrant deep-water corals and sponges. Hydrothermal vents gush scalding mineral-rich water into the icy depths, sustaining oases of giant tube worms, ghostly crabs, and eyeless shrimp in the endless night. Perhaps most marvellous of all are the denizens of the Hadal depths, the ocean trenches that plunge to 20,000 feet and more. Here, in the deepest places on Earth, the pressure exceeds 1,000 times that at sea level, enough to crush a human body to pulp. Yet even here, life finds a way. The Mariana snailfish, translucent and delicate as gossamer, thrives at the bottom of its namesake trench, flitting over the silty seafloor on wing-like fins. Amphipods, distant relatives of sand fleas, scuttle about in armoured exoskeletons, some grown grotesquely large in the absence of predators, and the enigmatic Xenophyophores, giant single-celled organisms sheltered in honeycomb towers, may be the most abundant life form in the Hadal realm. From the haunting wails of a pod of sperm whales diving to battle giant squid in the lightless depths, to the frenetic twinkle of a pyrotechnic display of bioluminescence, the abyss is not a silent, barren place, but a world vibrant with life. Its inhabitants, long adapted to that unending night, face new perils as the impacts of human activity reach down from the sunlit surface. Bottom trawling gouges scars in the seafloor, acidification erodes the skeletons of abyssal coral gardens, and mining interests eye the mineral riches that could be ripped from the deep. As we continue to explore this last great wilderness of our planet, we must also strive to preserve it and its myriad denizens. The deep ocean remains the least known environment on Earth, a realm where every expedition discovers new species and unimagined landscapes. From the first intrepid naturalists who dared to imagine life in the depths, to the revolutionary technologies that carry us down into the darkness today, we've only just begun to fathom the secrets of the abyss. The wonders we've glimpsed so far are but a fraction of what still lies waiting in that alien world below. As you drift off into the comforting darkness of sleep, ponder for a moment that hidden universe beneath the waves, where, in the words of William Beebe, myriad creatures joyfully and colourfully live their lives in an eternal night. Through the quartz windows of the bathysphere, the inky void of the abyss pressed in from all sides. William Beebe and Otis Barton, suspended by a slender cable from the research vessel far above, peered out into an alien world no human eyes had ever seen. As they descended deeper and deeper, the sunlight filtering down from the surface grew ever dimmer, until at last only the glow of their flashlight pierced the eternal, frigid night. The date was August 15th, 1934, and Beebe and Barton had just become the first humans to lay eyes on the denizens of the deep ocean. When their bathysphere, a hollow steel ball less than 5 feet in diameter, reached a depth of 3,028 feet, 923 meters, they stopped to gaze out in wonder at a realm that had previously only been glimpsed in fleeting net trawls and dredge samples hauled up by ships far above. Through the thick quartz and steel, Beebe beheld visions that seemed to defy reality. Billowing veils of bioluminescence rippled past in the darkness, emanating from creatures so delicate and diaphanous they seemed scarcely more than living light. Nightmarish fish with gaping maws lined with needle-like teeth appeared suddenly out of the blackness, before vanishing again like spectres. And all around, suspended in the water like constellations, countless sparks of light flickered on and off, hinting at a world of abundance beyond the reach of their probing flashlight beam. For over a century before Beebe's landmark dive, scientists had been gradually piecing together a picture of what lay in the uncharted depths. In 1818, the British researcher Sir John Ross was the first to sound the deep ocean using a weighted line, recording an astonishing depth of 2,700 metres in the Arctic basin. Subsequent expeditions using improved hemp ropes and eventually steel cables would reveal that the oceans were far deeper than anyone had imagined, plunging down over 10,000 metres in the deepest trenches. These early-sounding weights occasionally returned with clumps of mud or clay clinging to them, sometimes containing shells or worm tubes hinting at life on the abyssal seafloor. But most scientists at the time believed that the immense pressure, pervasive darkness, and frigid cold precluded the possibility of life existing in the depths of the abyss. The prevailing theory, promoted by the British biologist Edward Forbes in the 1840s, was the Azoic hypothesis, which held that no life could exist below about 600 metres deep. It was the voyage of HMS Challenger from 1872 to 1876 that would begin to overturn this assumption. Over the course of their pioneering oceanographic expedition, which circumnavigated the globe and covered nearly 70,000 nautical miles, scientists aboard the Challenger dredged up thousands of deep-sea specimens from every depth and region they sampled. Delicate glass sponges, otherworldly cephalopods, and creatures that seemed to be living fossils from bygone eras were pulled from the abyss, painting a picture of the deep ocean as an oasis of life rather than a barren underworld. In the decades following the Challenger expedition, new technologies would allow researchers to probe ever deeper and paint an increasingly vivid picture of the abyss. In the early 1900s, the research vessel Albatross used steel cables to lower trawl nets down to unprecedented depths, hauling up creatures like gulper eels and anglerfish that would capture the public imagination and cement the deep sea's reputation as a realm of monsters. But it was Beebe and Barton's bathysphere dives that would open a new era of deep ocean exploration, allowing humans to observe the abyss with their own eyes for the first time. As Beebe descended into the depths that fateful day in 1934, he marvelled at the parade of lifeforms drifting past the bathysphere's windows. Bioluminescent fireworks displays from creatures ranging from delicate jellyfish to bristling shrimp lit up the darkness. A phantasmagorical bestiary of deep sea fishes appeared as if in a dream. Fanged viper fish with sinister glowing lures, rotund gulper eels with cavernous mouths, and eerie anglerfish waving bioluminescent lures of their own to attract unwary prey. But perhaps most remarkable were the glimpses Beebe caught of the abyssal seafloor itself, an alien landscape of rippled ooze and jutting rock formations untouched by the sun's rays for eons. In that cold, lightless world, Beebe observed delicate creatures going about their lives as they had for millions of years, indifferent to the world above. Gossamer sea spiders tottered over the bottom on stilt-like legs. Gelatinous sea cucumbers ingested mouthfuls of nutrient-rich mud, and scuttling brittle stars picked their way among forests of glass sponges. It was a realm of unearthly calm and slow, dreamlike motion, where the usual rules of the sunlit world seemed not to apply. In the absence of light, many creatures had evolved to be transparent or clad in shades of black and red that rendered them all but invisible. Metabolisms had slowed to a crawl in the icy cold, with meals few and far between in the food-poor abyss. And all the while, a gentle rain of organic detritus, marine snow, drifted down from the prolific surface waters miles above, providing sustenance to the abyssal plain. As Beebe and Barton ascended back to their world after half a mile of sinking into the deep, they carried with them a newfound appreciation for the wonders that lay hidden beneath the waves. Even today, with all our advanced technology, we have still explored less than 10% of the global ocean floor. The depths remain the largest and least understood habitat on our planet, a final frontier holding mysteries we can scarcely imagine. Modern oceanographers, following in the footsteps of pioneers like Beebe, continue to push the boundaries of our understanding of the deep. High-resolution mapping systems have revealed the abyssal plains to be anything but featureless. They are riven with mountain ranges, trenches, and vast underwater canyons. Remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, allow us to survey the depths for longer periods and across greater distances than any human-crewed vehicle. And each time they venture into the abyss, they return with images of creatures and seascapes more wondrous than the last. Perhaps most fascinating are the oases of life that punctuate the abyssal desert. Hydrothermal vents, first discovered in 1977, spew superheated water laden with minerals and chemicals from cracks in the seafloor, and host thriving communities of organisms found nowhere else on Earth. Tube worms, clams, and crabs have all adapted to harness the energy from these vents, forming the basis of unique food chains that require no input from the sun above. Similarly, cold seeps and whale falls provide hotspots of nutrients that draw in scavengers and settlers from miles around, capitalizing on these sporadic feasts. It is a world that operates on its own timeless rhythms, indifferent to the frenetic pulse of life in the sun. In the deep, many creatures live for decades or even centuries, growing slowly in the frigid dark. Some corals and sponges are thought to be among the oldest animals on the planet, with specimens dated to over 4,000 years old. In the lightless depths, beyond the reach of the sun's nourishing rays, life has carved out its own rules for survival. As we drift off to sleep, we might imagine sinking down into that world ourselves, leaving the bright, busy realm of the surface behind. Down and down we go, past the warm, sunlit layers, through the twilight zone where the last rays of light fade to black. Deeper still, to the abyssal plain, a world of eternal night, where pressure crushes down with the weight of miles of water overhead. And yet, even here, life finds a way. As our eyes adjust to the darkness, the abyss gradually reveals itself in all its strange splendor. Sinuous shark silhouettes glide past with nightmare grace, their soulless eyes reflecting pinpricks of bioluminescence. Fist-sized amphipods scuttle over dunes of diatomaceous ooze, filter feeding on the snow of organic detritus sinking from above. A Dumbo octopus flaps its ear-like fins and drifts off into the gloom, a spectral Cheshire cat grin dissolving in the dark. This is a world beyond our daily cares and struggles, a liminal space between the surface and the unknown. As slumber takes hold and the waking world recedes, the siren song of the abyss beckons us down to lightless realms. It is a soothing void, a dreamscape of liquid midnight where time seems to hold no sway. Even as we sleep, that alien world carries on in its ceaseless rhythms far below, a reminder that the planet we inhabit holds wonders beyond our imagining in its most remote reaches. So let the deep sea's eternal dream cradle us in its darkened depths. Let the miles of water above us become a caress, a cocoon against the world of light and air. And let sleep become a journey to that final, fathomless frontier where monsters and marvels still roam undisturbed. Here in the abyssal night, cradled in a lullaby of slow tides and settling snow, we can abandon the frenetic tempo of life above. As we slumber, the denizens of the deep carry on their patient vigil, as they have for eons. Someday we may yet unravel all the mysteries these sightless depths conceal, but for now we can only visit in our dreams, sinking into the soft, silent abyss where time, light and life all fade to black. Sweet dreams from the eternal night of the deep. The deep sea is truly Earth's last great unexplored frontier. With every expedition, researchers discover completely new species, ecosystems and mysteries that overturn our understanding of life on this planet. Just recently in 2020, a joint US-UK expedition to the Clarion-Clipperton zone of the Pacific Ocean uncovered over 30 new species, from glass sponges to sea cucumbers to octopuses. And yet this survey only scratched the surface. Scientists estimate there could be millions more unknown creatures dwelling in the abyss. But even as we marvel at the richness of deep sea life, this alien world is increasingly under threat from human activities. Climate change is warming the oceans and acidifying the water, putting stress on delicate deep-sea corals and other temperature-sensitive creatures. Bottom trawling by fishing fleets scrapes 2.5 million square miles of seafloor each year, ripping up slow-growing sponges and decimating seamount communities. Proposed deep-sea mining operations for valuable metals could soon carve up vast swaths of pristine abyssal plain. If there's one thing the history of deep-sea exploration has taught us, it's how much we still have to learn about the depths. Over 80% of the ocean remains unmapped and unobserved by human eyes. The creatures down there have existed for eons in the darkness, under crushing pressures, on meagre rations. Now their realm faces a threat like never before. How many wondrous animals will vanish before we even know they exist? What marvels of evolution will be lost forever to the insatiable human appetite for exploitation? Perhaps one day, tourism to the deep sea will be as common as voyages to outer space. Already, submersible joyrides to the Titanic wreck and Challenger Deep are available to those with means. Maybe in the future, vacationers will flock to the thermal spa vents of the Mid-Atlantic Ridge, or marvel at the eerie, bioluminescent light shows of the benthic zone. With new battery technology and lightweight materials, AUVs could glide for months in the abyss, live streaming the sights via digital telepresence. But for most of us, the abyssal realm will always remain a mysterious otherworld, as remote as the moons of Jupiter. A place we may only visit in our most fanciful dreams, as we drift off into the welcoming darkness of sleep. Down there, in the endless night of the deep, the bone-white crabs and eyeless fish carry on their lives as they have for millennia. Slow lives, pared down to the essentials, metered out over centuries. The deep sea is a reminder of how fleeting our own existence is, in the grand scheme. While we slumber, the eternal dance of predator and prey, life and death, plays out in the void as it has since the first creatures invaded the abyss. It's a humbling thought, that there are beings on our own planet so utterly unlike us, so far removed from the reality we know. And yet, we are connected to that world in ways we're only beginning to understand. The deep ocean is the crucible that forged all life on Earth. Every living thing can trace its ancestry back to the primordial soup of chemicals that first gathered around those ancient hydrothermal vents. The story of life's odyssey from sea to land is written in every bone of our bodies, in every twitch of our muscles. So as you nestle into your blankets, ready to slip into the comforting oblivion of sleep, spare a thought for the creatures of the deep. They may be out of sight and out of mind, but they are always there, living their unfathomable lives in the abyss. In a way, the deep sea is the closest thing we have to an alien world right here on Earth. A place of eternal darkness, filled with bizarre creatures that seem to defy the laws of nature. But the more we learn about the abyss, the more we realize how inextricably linked we are to that alien realm. The fate of the oceans is the fate of all life on this planet, from the plankton that produce the oxygen we breathe to the whales that fertilize entire ecosystems with their falling carcasses. What happens in the depths affects us all, whether we realize it or not. So as you finally surrender to the irresistible pull of sleep, drifting off into your own personal abyss, remember that you are part of something much larger. A tapestry of life that extends from the sunlit shallows to the Stygian depths, woven over billions of years of evolution. The mysteries of the deep may never be fully solved, but in our dreams we can imagine ourselves there, floating weightless in the infinite darkness, at one with the wonders of the abyss. As we've seen, the deep oceans are a realm of eternal darkness, where the pressure is immense, food is scarce, and temperatures hover just above freezing. In this harsh world, animals have evolved some truly extraordinary adaptations to carve out their existence. Take the Mariana snailfish, for instance. This small, tadpole-like creature holds the record for the deepest living fish ever discovered, found swimming a staggering 8,200 meters beneath the waves. At that depth, the pressure is over 1,000 times greater than at the surface, enough to crush a human like an aluminum can. Yet the snailfish's delicate, gelatinous body is perfectly adapted to withstand the squeeze. Its skeleton is light and flexible. Its muscles are infused with special oils to prevent them from locking up in the cold, and its cell walls are packed with molecules called piezolites that keep them from getting crushed. Snailfish spend their lives drifting gently through the abyss, grazing on tiny crustaceans and marine snow. Many other deep-sea creatures have evolved to be extremely gelatinous and fragile. This is because, in the deep, it's advantageous to invest precious energy into muscles and sensory organs rather than heavy skeletons and armour. The gulper eel, for instance, has a jaw and stomach that can stretch to engulf prey nearly as big as its own body, while the vampire squid has huge globular eyes to detect the faintest shimmer of bioluminescence. But bring these animals up towards the surface, and they rapidly deteriorate as their bodies cannot withstand the reduction in pressure. Bioluminescence is another common deep-sea adaptation. In a world of permanent darkness, producing your own light can help you attract prey, find mates, or camouflage yourself against predators. It's estimated that around 90% of deep-sea creatures can glow in one way or another. The anglerfish is perhaps the most famous example, with its long head stalk tipped with a luminous lure to draw curious prey into its cavernous, tooth-filled mouth. Some squid and crustaceans can even squirt clouds of glowing ink to distract predators while they make their escape. The deep is also home to some of the oldest animals on Earth. In the stillness and stability of the depths, many species are thought to live for hundreds or even thousands of years. The Greenland shark, for instance, is estimated to live over 400 years, making it the longest-lived vertebrate. The deep-sea sponge Monohaphis tuni has been found towering up to 3 meters tall, and with a growth rate of just a few millimeters per year, the largest individuals may have been slowly filter feeding for over 10,000 years. In the abyss, life tends to be slow, stretched out, and sustainable. But even in this realm of darkness, oases of life and colour can be found erupting from the seafloor. Hydrothermal vents are cracks where superheated water, rich in dissolved minerals and chemicals, comes geysering out of the Earth's crust. The scalding fluids can reach up to 400 degrees Celsius and are laden with toxic substances like hydrogen sulfide. Yet life thrives here in abundance. Entire ecosystems flourish around the vents, bathed in the warm, mineral-rich flow and sheltered from the cold, crushing pressure of the deep. The secret lies in chemosynthetic bacteria, microbes that can harness the energy in the hydrothermal fluid to make food, much like plants use sunlight. These bacteria form the base of the food chain, fueling lush communities of giant tube worms, clams, mussels, crabs, and fish that can withstand the harsh conditions. Some tube worms can grow up to 2 meters long, sheltering the bacteria inside their bodies in a symbiotic relationship. The microbes produce sugars for the worm, while the worm supplies them with oxygen, carbon dioxide, and a safe haven. Over 700 species have been discovered at hydrothermal vents since they were first stumbled upon in 1977. Each vent has a unique combination of mineral composition, temperature, and fluid chemistry that shapes the community living there. And when a vent eventually stops flowing and dies out, the entire ecosystem collapses and decays, leaving behind a whale-fall-like oasis on the seafloor for years to come as scavengers flock to feast. Perhaps even more peculiar than the vents are the deep hypersaline basins, or brine pools, that dot the bottom of the Gulf of Mexico and Red Sea. These are literally lakes within the ocean, with the heavy salt water forming distinct shores and depressions on the seafloor. The brine is so dense that submersibles can float on the surface, and sampling bottles can be filled from the lake like on land. But this water contains almost no oxygen, and is loaded with toxic methane and sulfur, it's deadly to most life. However, a few highly specialized creatures do thrive along the shores, like mussels and shrimp that have adapted to withstand the harsh chemistry. Predatory fish will sometimes drift over the brine to hunt, but must be careful not to stay too long or accidentally touch the surface, lest they be pickled to death by the deadly waters. In the brine itself, only a few hardy microbes make their living, forming a living scum that coats the lake floor like a salty bacterial mat. It's thought that these brine pools formed from the evaporation of ancient seas that once covered the area tens of millions of years ago. As plate tectonics shifted and oceans receded, massive salt deposits were buried under sediment and squeezed by the pressure into concentrated brine. This brine then seeped up through the seafloor at faults and collected in the depressions we see today, salty time capsules from a long-lost past. But brine pools aren't the only evidence of microbial life far beneath the seabed. All throughout the deep oceans, a deep biosphere of microbes ekes out a living buried inside the mud and rock of the seafloor. These hardy organisms survive without sunlight or oxygen, slowly munching away at nuggets of organic matter or sips of chemical energy. They live life in extreme slow motion, with a single cell division taking hundreds to thousands of years in the most barren sediments. It's estimated that the total biomass of the deep biosphere could exceed that of all other life on Earth. After all, the ocean floor is a vast continuous habitat, with cracks and crevices extending kilometers down into the crust. If you took all the water out of the oceans, the dried-out seabed would be a global desert of mud, ooze, and rock, pockmarked with hypersaline lakes, hydrothermal geysers, and minerals leaching from the sediment, and it would be crawling with an astronomically large underground ecosystem of bacteria, archaea, and fungi. Recent expeditions have even found life in the deepest, most inhospitable corners of the abyss. The Mariana Trench extends almost 11,000 meters down into the crust. If you placed Mount Everest inside it, the peak would still be over a mile underwater. The pressure at the bottom exceeds 1,000 atmospheres, or the equivalent of having 50 jumbo jets stacked on your head. The water temperature hovers just a few degrees above freezing. It's hard to imagine life surviving in this most extreme environment on Earth. Yet when James Cameron made his historic solo dive to the bottom in 2012, he was stunned to see life through his tiny window. Delicate, ghostly fish flitted through his lights, and shrimp-like amphipods danced along the seafloor. Later analysis would find that these Mariana snailfish and Hirondelia gigas amphipods were distinct species, superbly adapted to the unique conditions of the trench. The snailfish had high levels of the pressure-stabilizing molecule TMAO in their muscles, while the amphipods had evolved aluminum suits of armor to withstand the squeeze. Even more shocking was the discovery of microbes living in the sediment at the bottom of the trench. Despite the immense pressure, total lack of light, and scarcity of nutrients, bacteria, and archaea were found in higher abundances than expected, slowly metabolizing the detritus that rained down from miles above. Some were even able to survive and reproduce samples brought back to the surface. The Mariana Trench was not a lifeless void, but an alien oasis at the furthest reaches of where life could take hold. This may have profound implications for the possibility of life on other worlds. If bacteria and archaea can survive in the deepest, darkest, most hostile places on our planet, then perhaps we shouldn't rule out the existence of life in the more extreme corners of the solar system. Could there be microbes lurking in the underground oceans of Europa, or clinging to hydrothermal vents on the seafloor of Enceladus? Might there be entire ecosystems sheltered beneath the frozen surface of Pluto, powered not by the sun but by radioactive elements and chemical reactions in the depths? The incredible tenacity of life in Earth's abyss suggests we should keep an open mind. As we've seen, the history of deep-sea exploration is one of continually having our expectations overturned. 2 centuries ago, Edward Forbes proclaimed the oceans below 1,800 feet to be a lifeless Azoic zone. Yet now we know that life thrives all the way down to the deepest trenches. We used to think that the deep was a vast, continuous void of mud and ooze. Yet now we know it's dotted with hydrothermal wonderlands, brine lakes, and whalefall oases rich in unique species. And we used to think that the seafloor was a static, barren place. Yet now we know it's home to an enormous underworld of microbial activity, cycling nutrients and energy in the darkness. There is still so much left to discover about the alien world far beneath the waves. Whenever a new expedition ventures into the abyss, they invariably come back with footage and samples of creatures never before seen by human eyes. We've only explored and mapped a tiny fraction of the deep sea floor, and even less of the water column above it. Every submersible dive has the potential to stumble upon strange new ecosystems, living fossils from bygone eras, or novel biochemistries and survival strategies. The deep holds answers to some of the biggest remaining questions in science: the origins of life, the extremes of habitability, the future effects of climate change. The abyss beckons. Perhaps someday, in the far future, we may establish permanent colonies on the seafloor, as we're now attempting to build on the Moon and Mars. Imagine cities under the sea, nestled in protective domes near hydrothermal vents and brine pools, harvesting the chemical and mineral riches gushing from the Earth, while studying the extremophile life forms up close. Maybe we'll even develop ways to modify our own biology, to withstand the pressure and breathe the fluids, becoming true citizens of the deep. It's a captivating thought to drift off to sleep to. But for now we can marvel at the wonders that await us in the inky depths of our own planet, an alien landscape more spectacular than anything dreamed up in science fiction. As you slip into slumber, picture yourself sinking slowly into that endless velvet night of the abyss, watching as the shimmering life of the surface gives way to the glowing specks and sparks of bioluminescence in the darkness below, like the stars emerging in the night sky. Sink past the concealing red-black skin of the crunchyed squid, the watchful eyes of the viperfish, the twinkling lure of the anglerfish. Sink past the bone-eating worms and crabs swarming over a whale fall, the tube worms and crabs basking in the glow of a hydrothermal vent, the microbial mat shimmering along the shore of a brine lake. Sink and sink until even the Mariana snailfish and TMAO-laden amphipods cannot follow, and you are engulfed by the primordial ooze of the deepest seafloor, where the bacteria toil silently in the depths, as they have for billions of years. Down here, in the cold eternal darkness of the abyss, a whole alien world carries on, and the mysteries it still holds for us are beyond our most extraordinary dreams. As you finally let sleep overtake you, remember that the deep is not a dead, empty void, but a living, breathing, endlessly fascinating hidden realm, ready and waiting for when humanity next dares to take the plunge into the unknown. For now, rest well and dream of the marvels in the deep. As we've seen, the deep oceans are not the lifeless voids they were once thought to be. They are home to an astonishing diversity of life forms, each exquisitely adapted to the challenges of their extreme environment. One creature that perfectly embodies the alien nature of the abyss is the anglerfish. Imagine a gaping mouth filled with needle-sharp teeth, attached to a body that seems to be all head and no tail. Sprouting from its forehead is a long, thin appendage tipped with a glowing lure. This is the anglerfish's bioluminescent fishing rod, used to attract curious prey in the darkness. There are over 200 species of anglerfish, and some of the most fascinating are the deep-sea varieties. In a stunning example of evolutionary adaptation, the tiny male anglerfish actually fuses to the much larger female, becoming a permanent sperm-producing appendage. This bizarre reproductive strategy ensures that when the female is ready to spawn, a mate is always at hand, or rather, at body. Another icon of the deep is the giant squid. For centuries, this elusive creature was the stuff of legend, with tall tales of tentacled monsters dragging ships to their doom. But in truth, the giant squid is a more fragile beast. Growing up to 13 meters long, its eyes are the size of dinner plates, the largest in the animal kingdom. Yet for all its bulk, the giant squid's body is remarkably soft and gelatinous. That's because in the deep sea, bones and dense tissues are a liability. The immense pressure at depth would crush a heavily built creature. So many abyssal animals have adapted by trading firmness for flabbiness, developing watery, almost transparent bodies held together by not much more than collagen. We see this taken to the extreme in jellyfish and comb jellies, or ctenophores. These delicate, ghostly creatures are little more than pulsating bells of a jelly, trailing long tentacles to ensnare tiny prey. Some, like the bloody belly comb jelly, flash with bioluminescent light, putting on dazzling displays in the eternal night. Speaking of eternal night, most of the deep ocean is shrouded in utter darkness, beyond the reach of even the dimmest sunlight. In this lightless world, the only illumination comes from the creatures themselves. Bioluminescence is remarkably common in the deep sea, with an estimated 90% of animals producing some form of living light. There are a myriad of reasons why deep-sea creatures flash and glow. For some, like the anglerfish, bioluminescence is a lure to attract prey. For others, it's a defense mechanism to confuse predators or a way to communicate with potential mates. Some creatures even use bioluminescent cloaks to disguise their silhouettes against the faint light filtering down from above. One of the most astonishing light shows in the depths is the shimmering display of a startled vampire squid. When threatened, this strange cephalopod unfurls a cloak-like web of skin between its arms, which is dotted with glowing photophores. As it undulates gracefully through the water, the vampire squid appears to vanish and reappear in a mesmerizing game of hide-and-seek. But light isn't the only way to hide in the deep sea. In a world without colour, many creatures have evolved to be completely transparent. This allows them to blend into the featureless background and avoid the probing eyes of predators. One such master of invisibility is the glass squid, whose entire body is as clear as crystal, with only its shimmering eyes and flickering chromatophores giving it away. At the other end of the spectrum are creatures cloaked in red and black. In the dim blue light of the twilight zone, these colours appear almost identical to the empty void. A prime example is the deep-sea dragonfish, whose jet black skin and dagger-like teeth make it a phantom of the abyss. So why is the deep sea dominated by these particular hues? It all comes down to the physics of light in water. As sunlight filters through the depths, the long red wavelengths are quickly absorbed, leaving only the shorter blue wavelengths behind. That's why the open ocean appears a vivid blue from above, but fades to a murky twilight, and finally complete blackness as you descend. For creatures seeking to hide in this alien world, red and black are the perfect camouflage. But there's a twist. Many deep-sea predators have actually evolved the ability to produce and detect red light. The dragonfish, for example, wields red bioluminescence like a sniper scope, illuminating hapless prey while remaining invisible to others. It's just one of the many remarkable adaptations that allow life to thrive in one of the most inhospitable environments on Earth. From the delicate wisps of a siphonophore's tentacles to the cavernous maw of a gulper eel, each creature is a marvel of evolutionary engineering shaped by the relentless pressures of the deep. And yet, for all their alien strangeness, there is a haunting beauty to the inhabitants of the abyss. As they drift through the inky depths, these creatures seem almost dreamlike, more akin to the fanciful imaginings of a sleeping mind than flesh and blood organisms. Perhaps that's what makes the deep sea such an enduring source of fascination. It's a realm where the boundaries between reality and imagination seem to blur, where the familiar rules of life are suspended in favour of something altogether more otherworldly. As we continue our journey into the depths, we'll encounter even more wonders and mysteries. From the towering hydrothermal vents that sustain entire ecosystems in the lightless abyss, to the haunting graveyards of sunken whales, each new discovery reveals just how much we still have to learn about the alien world beneath the waves. But for now, as we drift off to sleep, we can let our minds sink down into the inky darkness, marvelling at the extraordinary creatures that call this strange realm home. In the deep, dreams and reality intertwine, and the impossible becomes simply another facet of the endlessly surprising tapestry of life on Earth. As we've seen, the deep oceans remained a mystery for much of human history, with the prevailing belief being that no life could possibly exist in the eternal darkness and crushing pressures of the abyss. It took a series of intrepid expeditions, each venturing deeper than the last to gradually reveal the alien world thriving beneath the waves. One of the most ambitious and revealing of these expeditions was the voyage of HMS Challenger from 1872 to 1876. Funded by the British Royal Society and the Admiralty, Challenger was a floating laboratory, kitted out with state-of-the-art scientific equipment and a crew of expert naturalists. Over the course of 4 years, the ship crisscrossed the globe, covering nearly 70,000 nautical miles and sampling the oceans at regular intervals down to the unprecedented depth of 5 miles. At each of the Challenger's 362 sampling stations, weighted sounding lines would be lowered over the side to measure the depth of the seafloor, Then, large trawl nets and dredges would be dragged along the bottom, scooping up samples of mud, rocks, and any creatures unlucky enough to be caught. These samples would be hauled back to the surface for the scientists to eagerly examine, and what they found defied their wildest expectations. In every net, at every depth, the Challenger crew discovered life, from delicate, transparent sea cucumbers to nightmarish viperfish with dagger-like teeth, from bizarre tentacled comb jellies to giant single-celled organisms called xenophyophores. The diversity of deep-sea life was astounding. Even in mud dredged from the deepest trenches, the naturalists were amazed to find living bacteria, disproving Forbes' theory that life could not exist below 1,800 feet once and for all. The sheer volume of discoveries from the Challenger expedition was staggering. By the end of the voyage, over 4,700 new species had been catalogued, a number that has only grown as modern taxonomists continue to sift through the pickled specimens. The final report on the expedition filled 50 immense volumes, and perhaps most importantly, the Challenger showed that life could thrive even in the most extreme and inhospitable environments on Earth. Building on the Challenger's success, other nations launched their own deep-sea expeditions in the early 20th century, each probing the depths more thoroughly than the last. From 1899 to 1900, the Dutch HNL Marasiboga explored the basins of the Indo-Pacific, cataloguing thousands of new species of crustaceans, corals, and mollusks. Around the same time, the US Fish Commission ship Albatross was making record-breaking trawls with a new steel cable, pulling up nets bursting with strange deep-sea fishes from down to 3,000 fathoms. But there was only so much these expeditions could learn from brief glimpses of deep-sea life, mangled and dying, pulled from the depths in nets. To truly understand how these creatures lived, someone would have to go down and observe them in their natural habitat, a feat long thought to be impossible. The pressure at just 1,000 feet down was enough to crush a human body, and the deepest reaches of the trenches could pulverize submarines like tin cans. Who would dare to descend into this blackness? The answer came in the 1930s in the form of two daring explorers, the American naturalist William Beebe and the engineering prodigy Otis Barton. Together, they designed a revolutionary vessel called the bathysphere, essentially a hollow steel ball with tiny inset windows of fused quartz, the only material strong enough to withstand the pressures of the deep. Beebe and Barton would seal themselves inside this claustrophobic sphere and be lowered into the depths on a steel cable from a ship above, quite literally dangling their lives by a thread. It was a daring gambit, rife with potential for disaster. If the cable snapped or the windows cracked, the two men would be instantly crushed. The air inside the sphere could turn toxic from their own exhaled carbon dioxide, and if the telephone line used to communicate with the ship above broke, they could drift untethered until their oxygen ran out, doomed to a slow, dark demise. Despite the risks, Beebe and Barton completed several successful dives in the bathysphere, becoming the first humans to lay eyes on the deep ocean realm. As they peered out through the thick quartz windows, they entered an alien world of eternal night, where even the strongest searchlights could only penetrate a few dozen feet. Strange, bioluminescent creatures drifted past in the darkness, flashing an electric blue. Gelatinous ctenophores pulsed with rippling cilia. A gulper eel gaped its massive sail-like jaws. It was a glimpse into a world utterly unlike our own, and Beebe's vivid accounts of these dives captured the public imagination. On August 15th, 1934, Beebe and Barton made history with a record-breaking descent to 3,028 feet, deeper than any human had ever ventured. Though a stray swordfish punctured the cable on the way down, nearly dooming the mission, the bathysphere held firm against the crushing pressure. And as Beebe looked out into the gloom, he spied a small, dark form drifting past, its light glowing an entrancing violet before fading to embers. It was a previously unknown species of anglerfish, luring prey with its bioluminescent lamp, later named Bathysphaera intacta in honour of Beebe's intrepid vessel. The bathysphere dives of the 1930s cracked open a window into the deep sea, but much of this dark realm still remained inaccessible and unexplored. It would take the advent of new technologies, advances in sonar, submersibles and robotics forged in the pressures of World War II and the Cold War, to truly begin to plumb the ocean depths. But Beebe and Barton had taken the crucial first steps, proving that the abyss was not the barren wasteland that Forbes had imagined. It was a thriving oasis of life, stranger and more spectacular than the most fanciful myth or fable. As you drift off into the soothing darkness behind your eyelids, try to picture Beebe's and Barton's first glimpse into the void. Imagine the faint cobalt glow of a viperfish flashing past the windows, its diaphanous fins fluttering gently in the current, or the spectral dart of a phantom anglerfish, luring unseen quarry toward its needle-like teeth. Even now, we have only seen a fraction of the creatures that call the abyss home. Every submersible dive and remote robotic mission reveals new species beyond human imagination. The deep holds endless mysteries yet to be discovered, a prospect to mull over as you slip into the restful abyss of sleep. As we've seen, the oceans conceal a realm so alien and inaccessible that for much of human history it was scarcely even known to exist. What little was hauled up from the abyss, the occasional bizarre creature entangled in a fisherman's net, or a monster carcass washed ashore, was the stuff of myth and wild speculation. It seemed impossible that life could flourish in the frigid, sunless depths, but flourish it does. As improbable as it seemed to early scientific thinkers, we now know the deep ocean to be teeming with life. It's an ecosystem of unfathomable scale and complexity, sheltering creatures more diverse and more numerous than all the world's rainforests and reefs combined. To truly appreciate just how remarkable this is, we must remember the formidable challenges that confront life in the deep. Chief among them is the crushing weight of water overhead. For every 10 meters of depth, pressure increases by about the equivalent of Earth's entire atmosphere. Descend to the average depth of the ocean, around 4,000 meters, and you'd be pinned beneath a mass 400 times that of the air at sea level. Few creatures from the surface could survive such a squeeze. But as the pioneering oceanographers of the 19th and early 20th centuries would discover, life finds a way. Aboard the HMS Challenger in the 1870s, wide-eyed scientists hauled up thousands of deep-sea species never before seen by human eyes. Fish, mollusks, crustaceans, corals, sponges, an entire menagerie of life adapted to conditions that seemed intolerably harsh. Many of these animals looked downright bizarre to their collectors, all flabby flesh, gelatinous and translucent, with feeble muscles and watery blood. At the surface they swiftly perished, but this is the paradoxical secret to their survival in the abyss. Where pressure would rupture the gas-filled swim bladders of surface fish, deep dwellers simply do away with these buoyancy aids entirely, their tissues instead laced with lightweight fats and oils. The scarcity of food is another defining feature of the deep, and another driver of strange anatomical adaptations. In the lean times between rare feasts, many predators simply allow their bodies to waste away, their bones demineralizing, their muscles atrophying to a bare minimum. Some, like the pelican eel, evolved gargantuan mouths and expandable stomachs to engulf prey as big as themselves when the opportunity arises. Prey too have their bag of tricks. To elude the gape of predators' jaws, they turn to camouflage. In the gloaming of the twilight zone around 1,000 meters down, silvery scales reflect the remnant blue light filtering from above, rendering the animals all but invisible. Deeper still in the umbral darkness, the color palette turns to black and red, hues that are absorbed rather than reflected, and therefore imperceptible in the blackness. But of all the deep sea's visual marvels, none is more ubiquitous than bioluminescence. Everywhere you look, creatures carry their own onboard lights, like the phosphorescent paint daubed on a watch face. Delicate jellies pulse with an internal glow, shrimp wave lanterns to attract mates, anglerfish dangle luminous lures to draw prey into toothy traps. Down here, light is life. So much so that even in the deepest trenches and abyssal plains, as much as 90% of creatures are thought to wield some form of bioluminescence, by far the highest proportion of any environment on Earth. Some use it for camouflage, projecting light downwards to blend in against the faint glimmer filtering from above. Others deploy dazzling light shows as a distraction, or a lure, or a warning. There's so much more to the strange ways of deep-sea life than we can cover here. The sawtooth eels, with their hunting lights mounted on stalks, swiveling like spotlights. The barrel-leaf fish with transparent heads, their eyes perpetually gazing upwards through their skull. the hairy anglerfish, trailing whisker-like filaments from bulbous protrusions all over its body. One could devote an entire documentary to the anglerfish alone, those hideous poster children of the deep, and surely some of evolution's most whimsical creations. You might be familiar with the females, with their cavernous jaws and dangling bioluminescent lures. But what of the males? In some species, these diminutive creatures latch onto the females with their teeth, then permanently fuse to their mates' bodies, taking nourishment from her bloodstream. A single female may accumulate multiple males this way, hauling them around like a harem of parasitic spouses. Such is life in the deep, as fascinating as it is outlandish, where even the craziest of adaptations have some crucial survival role. But it would be a mistake to think of these creatures as perfectly at peace in their eternal darkness. They too have their trials and tribulations, their booms and busts, their feasts and famines. We see this most dramatically at sites of occasional bounty on the abyssal plains, those great flat expanses of ooze that cover much of the deep ocean floor, typically about as barren as deserts. When a whale dies and sinks, its carcass delivers to these plains an unthinkable windfall of food, equivalent to thousands of years' worth of the usual detrital rain from above. Scavengers swarm to the whale, fall from miles around. Hagfish, sleeper sharks, and crabs strip the skeleton clean, before an ecosystem of worms, snails, and bacteria move in to feast on the fats, saturating the sediment. A single whale can sustain such a community for decades, an oasis of abundance on the abyssal sands until the meal is finally spent. Similar boons come from sunken logs, which provide a rare resource for wood-boring clams and other deep-sea opportunists. Some scientists even speculate that such woodfalls might have provided stepping stones for the first shallow water species to colonize the deep, a theory lent credence by the presence of wood-eating limpets in the hadal zones of ocean trenches. More dependable bounty can be found at hydrothermal vents and methane seeps, where volcanic heat and chemical energy sustain thriving communities in the absence of sunlight. The iconic giant tube worms of the vents were only discovered in 1977, to the astonishment of the Alvin submersible's crew, who watched in awe as these 3-metre spaghetti monsters swayed in the shimmering vent fluids. Equally peculiar are the seep's ice worms, which tunnel through methane ice, not frozen water, but methane trapped in a crystalline cage. These worms graze on bacteria that in turn feed on the methane, a deep-sea symbiosis powered not by the sun, but by the Earth's internal heat. Other oases are less dependent on geothermal energy, or scarce influxes of food from above. Seamounts, those underwater mountains thrusting up from the ocean floor, deflect deep currents and corral nutrients, attracting swarms of plankton, fish, and higher predators. Some are capped with lush gardens of filter-feeding corals and sponges, which strain sustenance from the passing flow. Similar deep-water coral gardens are found on the continental slopes, where they structure habitat for countless other species. But unlike the ephemeral communities of the abyssal plains, these corals are extremely slow-growing and long-lived. Some are thought to exceed 4,000 years in age. It's a reminder that while some parts of the deep sea pulse to the rapid cadence of feast and famine, others live life in the slow lane, where animals measure their lives in centuries or millennia. And then there are the creatures that seem scarcely to live at all, like the infamous living fossils of the deep, which persist almost unchanged since the age of the dinosaurs or beyond. The coelacanth, a hulking armour-scaled fish, was thought extinct for 66 million years, until a specimen was hauled up off South Africa in 1938. The prototype for all the world's terrestrial spiders and scorpions, the horseshoe crab, tramps along the seabed much as its ancestors did more than 400 million years ago. What is it about the deep that has preserved these species in seeming evolutionary stasis for so long? Part of the answer may lie in the stability of their environment. Down here, temperatures have scarcely wavered since the age of the dinosaurs. There are no seasons to speak of, no ice ages come and go. While the continents above have wandered and collided, while mountain ranges have thrust up and eroded away, the deep ocean basins have endured largely unchanged for hundreds of millions of years. Perhaps in an environment so constant, in a world where the pace of life creeps so slowly, the forces of evolution likewise take a more leisurely course. The deep sea is in many ways a window into the past, sheltering not just individual relic species but whole ecosystems that have persisted since the dawn of complex life on Earth. But this is not to say that the deep is beyond our influence. On the contrary, human activities already reach into every last recess of the ocean, even if our understanding of these environments still lags far behind. Bottom trawlers scrape great furrows through the silt, pulverizing centuries-old coral gardens. Seabed mining threatens to dredge up metal-rich nodules, along with the unique creatures that depend on them. Carbon dioxide from our cars and factories finds its way to the deepest trenches, slowly acidifying the water and dissolving the calcium carbonate shells and skeletons on which so much of abyssal life depends. Our imperative to understand the deep has never been more urgent. Every expedition reveals completely new species, ecosystems, and even branches on the tree of life. We're still discovering creatures that defy our understanding of what life even is, like the xenophaeophories, those plate-sized amoebas that are the world's largest single-celled organisms, or the microbes living inside rocks, which may constitute a deep biosphere, rivaling all the rest of Earth's biomass. As we lie in bed, drifting off to sleep, it's a strangely comforting thought that the alien world of the deep carries on as it has for eons, sheltering forms of life beyond our wildest imaginations. It's a realm scarcely touched by the rhythms of our hectic world above, a bastion of constancy, where change is measured in the slow dance of currents, the gradual rain of sediments, the unhurried adaptations of evolution. But even here, in the stillness of the oceanic night, we're joined in some small way to the creatures of the abyss. The darkness behind our eyelids, the slow rhythm of our breath, the warmth of our bed, they're all part of the same elemental backdrop against which all of life plays out, from the surface to the sea floor. In sleep, as in the deep, we surrender to forces larger than ourselves, the fundamental pulse of life on Earth, which has endured for billions of years and will continue long after we're gone. Perhaps there's solace to be found in that. In the knowledge that however tumultuous the world may seem, however insignificant we may feel, we're part of an unbroken continuum of life that stretches back to the very origins of our planet. The same deep ocean that cradled the first living cells now buoys us in our slumber, imparting some sense of its own timeless rhythm. As we relinquish our conscious minds to sleep, we too enter a kind of abyssal realm, where the concerns of our waking lives recede into darkness and dreams hold sway. And like the creatures of the deep, will eventually emerge from this state refreshed, renewed, and ready to face the world above once more. But for now, we can simply marvel at the richness and complexity of life, in all its myriad forms from the surface to the seafloor. And as we finally slip into the restful oblivion of sleep, we can carry with us the knowledge that, even in the deepest, darkest places on Earth, life still finds a way. Good night. Seamounts are oases of life in the abyssal desert. These towering underwater mountains, born from ancient volcanic eruptions, rise thousands of meters from the seafloor, their rocky flanks encrusted with corals and sponges in a kaleidoscope of colour. Like islands in the sky, seamounts punctuate the seascape, disrupting the languid flow of deep currents. As water masses collide with these submerged summits, nutrients are thrust up from the depths, nourishing blooms of plankton that in turn feed an extravagance of life. Schools of vibrant fish swirl around the seamount's craggy peaks, while sharks and tuna prowl the fringes, drawn from miles around to these bastions of sustenance in the oceanic wasteland. In the crevices and caves of seamounts, smaller creatures find shelter. Lobsters, crabs, and octopuses squeeze into rocky nooks, their red and white carapaces contrasting with the muted tones of their surroundings. On the summits of underwater mountains that reach into the sunlight zone, kelp forests sway to the rhythm of the currents as parrotfish crunch on coral and sea stars cling to the rugged substrate. The isolation of seamounts makes them crucibles of evolution, where animals and plants adapt to their unique circumstances over millennia. Some seamounts host species found nowhere else on Earth, having diverged from their relatives in the uninterrupted flow of time in their secluded alpine keeps. Even as we marvel at the wonders of seamounts and abyssal plains, it's humbling to consider just how much of the deep ocean remains unexplored. the watery realm that blankets our blue planet largely eludes our grasp. When you contemplate the fact that Mount Everest would be lost beneath the waves if placed in the Mariana Trench, you begin to fathom the immensity of this liquid universe. And yet, for all the deep sea's inaccessibility to humans, it is far from untouched by our actions. The abyss is no longer out of sight and out of mind. Deep-sea trawling scrapes the seabed smooth, wiping out ancient coral groves before we even lay eyes upon them. Pollution and discarded plastics swirl into the depths, ensnaring and choking wildlife. Rising global temperatures and ocean acidification threaten to unravel the delicate balance of abyssal ecosystems. Perhaps most troubling are the nascent campaigns to mine the seabed for precious metals, potentially inflicting irreversible damage on the dark domain's habitats. The creatures of the deep have flourished for eons in obscure tranquility, but they now face an uncertain future as human influence extends into even the most remote recesses of the planet. Still, there is reason for hope. Just as our species' unquenchable thirst for knowledge led the earliest oceanographers to probe the deep, so too does that same curiosity inspire new generations of scientists and explorers to dedicate their lives to studying and protecting this final frontier. With every crude submersible dive, every robotic probe, and every high-resolution seafloor map, we pull back the watery veil just a little more, exposing hidden wonders and kindling new questions. Initiatives to create massive marine protected areas, limit the scope of deep-sea exploitation, and combat climate change gain traction with each passing year. The future of the abyss is not yet written. Even as we drift off into slumber, researchers and advocates carry on the work of safeguarding the deep, ensuring it remains a realm of marvels for generations of humans and fish to come. Perhaps someday, when science has illuminated more of the ocean's secrets, our dreams will be filled not only with fanciful mermaids and krakens, but with the phantasmagorical and very real creatures that haunt the depths. This video is but a glimpse into a world we barely understand, an invitation to ponder the mysteries that lurk beneath the waves. With any luck, our voyage through the history and majesty of the deep ocean has piqued your curiosity, as well as lulled you into a restful state. If you enjoyed this aquatic odyssey, be sure to like the video and subscribe to the channel. We have plenty more seaworthy science to explore together. Until next time, sweet dreams, and may your deepest dives be filled with wonder.